a box contains 5 red balls, 5 green balls, and 5 blue balls, right? So the balls are identical. I want to pick each ball got 1, 2, 3, 4, 5, so it can be like red 1, red 2, red 3, red 4, red 5, green 1, green 2, green 3, green 4, green 5, blue 1, blue 2, blue 3, blue 4, blue 5. Okay, find the probability that at least one red ball is drawn. Find the probability that at least one red. So we can also look at it as the probability, take 1 minus the probability that no red ball is drawn. That's also possible, right? So how do we find the probability that no red ball is drawn? 1 minus, there are total 5 red balls, right? Total 15 balls. So maybe the first one I can say I don't want any red balls. Okay, then I have 14 balls there. I can still don't want all the red balls, so I'm left with 9 choices. Also, that's one way. So I'll say it's just 4 over 7. Okay, or you can also see as 1 minus like 10 choose 2, the 10 blue and green I choose 2, over the total number 15 choose 2, which is also 4 over 7. Okay, this is for part 1. Part 2, the sum of the numbers, right, drawn is at least 9. This one we need to consider cases. Why? Because you can see there's so many possibilities, right? So there are a few possibilities. So number 1, it could be that I'm drawing 5, 5, correct? Number 2, I could be drawing a 5, 4, right? Or number 3, I can also be drawing like a 4, 5. Okay, so if I want to draw a 5, 5, it means that, you know, I'm going to, first of all, to get me a 5, I can have a blue 5, green 5, or red 5. So the probability of getting a 5 in the first attempt is 3 over 15. The second attempt, for me to get another 5 again, because there are only 2 5s left, right? If I draw a red 5, I'm left with a green or a blue 5, right? So the chance is 2 over 14 balls. Okay, how about if I want to draw a 5, 4? If I want to draw a 5, 4, first one, of course, is 3 over 15. Second one, to draw a 4, it will also be 3 over 14. There are 14 balls left, and 3 of them are with the number 4s. Okay, and you need to consider that not only 5, 4, I can also draw 4, 5, right? Right? So it's like also again 3 over 15 times 3 over 14. Right? So these are the possibilities for me to get at least a 9. So if I add all of them together, it's going to give you the final answer to be 4 over 35. Alright? So next, part 3. The sum of the numbers or the balls drawn is at least 9, given that at least one red ball is drawn. The sum of the numbers is at least 9. So probability that the sum is at least 9, given that at least one red ball is drawn. Okay, this will just be, let's look at the using the formula. This is the sum of at least 9 intersect this n, at least one red ball is drawn, over the probability that at least one red ball is drawn. Okay, so let's look at the numerator. The probability that at least 9, it could be, and at least one red ball, so it could be that you know, it has to be one of them. So it could be the red 4 is drawn, right? And out of the rest, right, we draw another ball. It could be green or blue. It could be green or blue 5, right? So it could be like green or blue, or also red, which is of the number 5, right? So this is the probability of like green or blue. Okay, the next one is that maybe I draw a red 5, and then again I can also draw maybe another green, blue, or red 5. So this will give me 10. Next one, I can also say I draw a red 5, and maybe I draw a green, blue. Can I be red 5? Cannot. Can only be red 4. So there are a total of 3 outcomes. Okay, the denominator at least one red drawn. This is just from part 1. Okay, so this is 4 over 7. And for numerator now, for this is just 3 choose 1 over 15. Maybe let's say 15 choose 2. 2 choose 1 over 15 choose 2. Plus 2 choose 1 over 15 choose 2. Over 4 over 7. And the answer comes out to be 7 over 60.